Hey, so welcome back, and this is another daily code problem. So today it was called optimal partition of a string, and once again this was another greedy problem, same as yesterday I think. And so here you're just given a string, and you want to output the minimum number of substrings in each partition. And so basically what you're going to do is you iterate through the string and try to create unique partitions. And a unique partition is just having a set of characters where they're all distinct, they're all unique. And so in this case, if we're iterating through the string, we just say, okay, A, B, and we stop there because if we include this A, well, that A has already been included before. So once again, you continue from onwards, so A, and then you include C, then you stop there because you can include A, and then you go A, B, and you stop there because you can't include this A, and then this is the fourth partition. Okay, and so that comes out as something like this, where you just have four different possible partitions where it's like A, B, A, C, A, B, A, or you can also do it this way. Now, what I actually just described to you is literally the algorithm. Initially, I thought of doing it as more of a backtracking brute force solution, where I'm trying to create every single permutation of the possible partitions. You see, I've seen questions before where you wanted to try all these different partitions in a string, and I immediately thought of that. And so I was writing like this recursive depth first search function. And so I was actually writing this core logic in that algorithm, but I didn't realize you could just do it this greedy way, where you're literally just starting from left to right. Every single time you hit another character that you've seen before, you just stop there and start creating a new partition and increment the count. Okay, so that's the algorithm. We're going to write it out, and I think once you see the code, it simplifies it. So it's O of n time, and that's because we're going to iterate through every character in our string, and it's O of 1 space, and that's because although we're going to be using like a use set here, we're adding characters to that set. The set can only be at most like 26 characters long because we're using all English letters here. And so this it won't scale like exponentially, like or even linearly, because it has like a constant cap on it. So yeah, let's continue onwards. So we're going to have a count that's initially 0, and this is the number of partitions that we have, and we're going to return at the end. And so what we're going to do is we're going to iterate through every character in our string, and we want to check, okay, if our character is used, so if we've already seen it before and we've already used it, then what we're going to do is we're just going to clear our use set, and then we're just going to increment our count. And so this is just mimicking, okay, we're creating a new partition from this point because, well, we've already seen that, okay, we did A, B, and now we've seen A now. And so we just greedily say, okay, let's create a new partition from this point on and just clear the values that we've used so far. Great. And so from there, all you do is, otherwise you're just going to add to our use set. And it's important not to put this in an if statement because you want to include the character that you are checking in this if condition. So you can just leave it like this, or you would have to do like else and then put that here. But it's just cleaner this way. Okay, and so this won't work. The only thing that you need is to add a +1 here. And the reason behind that is for the final case where, okay, you are now creating your fourth partition in this case, you're going to run out of bounds on that last case and you won't have incremented the count. So you just need to add a +1 to increment the count for the last partition that you've calculated. So yeah, that's today's algorithm. It's pretty straightforward, but greedy solutions are hard to come up with. You don't always recognize them immediately. I should have thought of doing it greedily. Since yesterday was a greedy solution, they typically do a trend, but I just didn't catch it. But yeah, I hope that helped, and good luck with the rest of your algorithms. Have a great day.